Okay, what we're going to look at today is how to evaluate integrals that have a trig function in them. Maybe. And these are trig functions that you can't just easily use something from your table or one that you know, something from your little cheat sheet. So I think it's easier. So our learning target is integrals with trig functions. We're going to look at one type today. We're going to look at when we have sine and cosine together because they go together. And the reason that they go together is because of sine squared um, plus cosine squared, that equals 1. So we're going to be using that fact today to evaluate. So let's look at this. We're going to integrate the cosine cubed of x times sine to the fourth of x dx. Now, the problem is you cannot just use a basic u substitution for sine or cosine because it wouldn't get rid of the cubed part. Like if I let u equal sine, it wouldn't get rid of cosine cubed. So what you have to do is you have to break this up. One general rule that I like to do, if I have cosine times sine, I look at the one that has the odd power. That's the one I'm going to change. Okay, so what I'm going to do is I'm going to just do some little algebra, manipulate this with algebra. I'm going to rewrite this as cosine squared of x times sine to the fourth of x times cosine of x dx. So all I did was break up the cubed into a squared times cosine. Then I'm going to come over here and use this little fact over here. Cosine squared of x is the same as 1 minus sine squared. So instead of putting cosine squared in, I'm going to put in 1 minus sine squared. So I get 1 minus sine squared times sine to the fourth of x times cosine of x. And the reason that I did all this is because eventually we're going to use a u substitution. And remember, the derivative of sine is just cosine. So before I do the u substitution, what I would do is I would distribute, and I would get sine to the fourth of x times the cosine of x minus sine to the sixth of x times the cosine of x dx. And now you can integrate. You know what I'm going to do? I'm just going to make these two different integrals because I can do that. So on this one, I'd let u equal sine of x. So du is cosine of x. So I'm integrating u to the fourth du. And on this one, I'd let u equal sine of x. And du is cosine of x. Or you could have left that all together as 1. I don't care. You get u to the 6th du. And you integrate, and you get u to the 5th over 5 minus u to the 7th over 7 plus c. And I'm going to substitute back in, so I get sine to the 5th of x over 5 minus sine to the 7th of x over 7 plus c is my answer. Okay? So there's one thing that can happen. Let's look at another one with sine and cosine. That one's kind of an easier one. How about sine to the 5th of x over the square root of the cosine of x dx? Now, same thing with what I set up here. This one has an odd power, so I think I would break that up. If I break that up, I get sine of x times sine to the fourth of x all over the square root of cosine of x. And then I'm going to go back up to my Pythagorean rule. Remember, sine squared plus cosine squared equals 1. So that means that sine squared equals 1 minus cosine squared. Therefore, sine to the fourth would equal 1 minus cosine to the fourth. So what I'm going to do now is substitute. I'm going to still have sine of x, but now I'm going to have 1 minus cosine to the fourth of x all over the square root of cosine of x. And now lots of algebra. Distribute. So I get sine of x minus sine of x cosine to the fourth of x all over the square root of the cosine. And break this up into two functions. So I have sine of x over the square root of cosine minus sine of x cosine to the fourth over the square root of cosine. Do one more little algebra trick. Maybe just rewrite this as sine of x times cosine of x to the negative 1/2. That's really what that is. Minus sine of x, and that would be, let's see, that'd be 8, so times cosine to the 7/2 of x, because I have 4 here, which would be 8/2 minus a half. So then if I integrate, I break this up into two little integrations because I like to do that. I can let u equal the cosine, and the derivative of that is a negative sine. Same thing here, u equals cosine, and the derivative is negative sine. So if I rewrite these, I get negative u to the negative 1/2. This one would actually become plus the integral of u to the 7/2, and we'll put du's after them. So if I integrate that, I get negative 2 square root of u plus, if I add 1, that's 9/2, so 2u to the 9/2 over 9 plus c, and u was cosine, so I get negative 2 square root of cosine of x plus 2/9 cosine to the 9/2 x plus c. That's it. Sine and cosine functions. Have a good day.